Hi everyone, Gary Bennett here, Wayne Parker's cameraman today. But today I'm going to do the talking. And today what we're talking about is how to set up your software, your dome control software, so that it can coordinate with telescope pointing position. So this actually doesn't have anything to do with PodMax, but of course we certainly like to be able to help you make your software work in sync. PodMax only reacts to a command to move the azimuth position, and your dome control software is the thing that does some pretty complicated math to try and translate where the dome is pointing with respect to the telescope. And when you think about what's going on, here in North America, in our location, we're at 45 degrees north latitude. So when you think about what's going on, the dome actually rotates on an axis that's parallel to Earth, but your telescope is, in our case, at a 45. So you actually have two things that are moving on two different planes, and there's some pretty radical math that goes on. And if you set it up right, it'll nail the slot pointing position exactly where it needs to, so that the telescope can have a view. So there are different dome control software applications, and they pretty well all want to know the same thing. Today we're going to use examples of what SkyX uses, and SkyX has a whole section in their manual. You're probably not going to be able to see this in the video camera, but basically what your dome control software needs to know is where the telescope is with reference to the center of the sphere. So PodMax, we only think that the sphere is the top half, but the sphere is actually going all the way around it, including underneath. So even the height of the telescope makes a difference. Now we have a lot of PodMax owners that struggle trying to get the slot to point the same direction that the telescope is in. And usually that's because they think they're saving time by just ballparking the settings in the software out. And my rule is shortcuts always end up taking way longer than doing it right in the first place. And the good news is it takes less than an hour. So the good news is that it takes less than an hour to really accurately measure the position of your telescope with respect to the center of the dome. And even builders who tried to put the telescope in the dead center of the observatory, it's usually off. No matter how hard you try, nothing is exact. And it's pretty easy to measure, and today we're actually going to show you a really simple technique that will get it right every time. Now what makes it hard is that finding the center of a round room is actually a little bit harder than you think, especially since you've got a telescope right in the middle of where you want to try and measure. So we're actually going to use the Dome Commander utility to help us mark off the major compass points, and we're going to show you how easy it is. And when we're all done, the only tools that we need is, I'm just going to pick up all my tools that I need to do this. You need a measuring tape. You need some painter's tape. You need some twine. You need a little marker device and a little washer that we're going to use to make a plumb bob. Okay, so the first thing we're going to do is we need a reference mark, and the most important reference mark of all is the one where we mark the center of the slot opening. So all we're going to do is we're just going to measure how far it is from one side of the wood arch to the other. We're going to find out what the middle point is, and then we're going to put a mark at the center of the slot opening. And then the next thing that we're going to be doing is we're actually going to be using a feature of the Dome Commander software where we're going to use this mark and we're going to make the dome rotate to 0, 90, 180, and 270 degrees. And whenever it stops on one of those marker points, we're actually going to make another mark there. And we're going to use those marks to actually hang a string from one side of the observatory to the other. And then we're going to do the other orientation. And then where those two strings cross is the exact center of the observatory. And then when we get there, we're going to show you what we're going to do. So the first thing we have to do in order to be able to hang a string, the telescope here sticks up a little high, so we're just going to undo the clutches and we're just going to move the telescope out of our way so that we can hang our strings. Okay, so now what we're going to do is we're going to use Dome Commander to actually mark the 0, 90, and 180 and 270 degree positions of the dome so that we can hang our strings. And all you're going to do is you're just going to launch Dome Commander. You're going to connect it to the whatever serial COM port that the dome is on. And after you connect it, first thing you're going to do is tell it to move to 0 position. So Dome Commander has now rotated the slot so that it's at 0 degrees azimuth, and now that it's there, you can see that what we've done is we've taken some of the painter's tape and we've marked on the lower ring here that mark. And you can also see we've put a little nail here, and that's what we're going to hang our string on. So now that we've made that mark, now we're going to go to Dome Commander, and we're not going to show, you know, every move that we're doing here, but all we have to do in Dome Commander is we just type 90, which is going to be 90 degrees, and then we press the go to azimuth, and when the dome stops, we're going to make another mark. So we asked Dome Commander to rotate the dome to 90 degrees, and it's finished moving now. So this was our original mark that marks the center of the slot, and now we're going to mark, and we're using a nail here because we're actually going to hang a string on here. And after this, we're going to go and ask it to go to 180 degrees. We're going to make another mark. We're going to ask it to go to 270 degrees, make another mark, and then we're done making marks. Okay, cut that. Okay, so we've taken our marks. We've pounded a little nail. You can also use those little, you know, picture frame eye hooks. And we've stretched the string from east to west and north to south. And where the two strings meet one another is the exact center of the observatory. And then what we've done is we've taken just a simple washer and another piece of string, and we've hung the string down from where the two strings cross. And this is exactly the center of the observatory. And now what your dome control software wants to know is where is the mount axis with respect to the center of the observatory. Right now, obviously, this is going to be north in this direction, and we can already see that the point that RA spins is right about in here, and we can see that our mount is actually this far from being the center. So you simply need to measure from this point to where your mount actually sits, and you've just got to plug that number into your dome control software. Likewise, it wants to know north-south relationship. We are we're pretty close to being right on the north, at exactly the center in the north-south direction. So, but still, it's off by a little bit, and you just need to picture that there's an imaginary line where the RA axis spins around, and then this counterweight shaft is your deck axis, and you just need to know how far of the imaginary line where these two axes meet, how far ahead are we or how far behind are we, and you just need to plug that number into your dome control software. And then the other thing that your dome control software wants to know is, from the axis point, where is the center of your optics? So you're simply going to measure how far is it from the axis position to where the center of the optics is. And in the case here, we actually have a second telescope that's piggyback mounted. And if you were using that telescope instead of this telescope, then you would simply set up another parameter where all of these measurements that you just did are exactly the same, but now the only difference is that the center of this optic is in a different place than the center of this optic. Now you can see what we've done here is we've put a little piece of tape and we've made a mark on it. So we were talking about, we've got this plumb bob thing happening, and that you're able to measure, how far to the west and the north and the south of this magic line your mount is positioned. But you can also see that we put a piece of tape here and we've marked it where the plumb bob touches it. And then this is a very important mark, because now you're going to wait until dark and you're actually going to use this mark to locate true north. You want to make sure that your zero azimuth is actually properly lined up with true north. And we're going to show you how, by using a simple green laser pointer, you can nail your true north position so that it's going to mark the center of the slot when the dome thinks that it's at 0 degrees azimuth. So we're going to pause the video and we're going to set it up for that scenario. And by the way, when you're making these measurements, the different dome control programs are a little bit different, but they all want to know the same information. We've got a lot of experience using the SkyX, but there's also MaxDL and a few others as well. We did notice though in the SkyX, again, it doesn't care whether you put the measurements in there in inches, centimeters, millimeters, whatever, as long as all the measurements use the same scale. But we did notice in the SkyX, it doesn't let you use fractions. So when you're all done, if you've measured it in inches, that's fine. But convert those inch measurements into millimeters, because again, the SkyX doesn't allow you to put a decimal in. So if you're at 20.7 inches or something like that, you either have to put in 20 or 21, and that's not exactly accurate. So if you convert that to millimeters, you can get it pretty darn accurate. Okay, so obviously we can't do this when it's actually dark outside, because you wouldn't be able to see the video. So let's just pretend that it's dark out now. And we're going to use this mark. This mark represents the center of the observatory. And now we have to make sure that where the dome thinks 0 degrees azimuth is in fact correct. So we're actually going to, if this were nighttime, we would have the slot open, and you're going to want to have a friend to help you do this, because what we're going to do is we're actually going to take a standard green laser pointer and we're going to set the bottom of the pointer down on this mark that we've made here, and we're going to turn the laser on and we're going to aim it at Polaris. And you can see we put a piece of tape up there, and the part that you need the friend for is that you don't really know how high to put this piece of tape. What you want to be able to do is to be able to have the pointer point at Polaris, and also be able to see the mark that you have on the piece of tape. That mark that's on there right now is actually the halfway point between the slot opening. And what the objective is to point the laser and align it with Polaris, and have the dome rotated to a point where the halfway mark that we made on the tape is exactly aligned with the laser that is pointing at Polaris. And if you find that the laser is pointing not on the center point, then what you actually have to do is rotate the dome until the dome is positioned exactly between this mark that we've made on the tape and Polaris. And you may have to do this a couple of times, but again, you want to rotate the dome until the center mark that you've made on the tape is aligned with Polaris. And then what you need to do is, you know, the magnet that we have that is the home position sensor, if you find that your location for 0 degrees azimuth was incorrect based on the exercise that we just did with the laser, that means you actually now have to move the magnet so that the magnet is behind the sensor when the center of the slot is aligned with true north. And that's really all there is to it. And this is usually the part that most PodMax owners get wrong, because what they tend to do is they come out and they kind of stand behind the pier and they eyeball where Polaris is in the center, and they're usually off. So this is a pretty simple way of doing it, and there's really no more accurate way of doing it than just to use a simple green laser pointer. It's very easy to do, and it's dead not accurate. So by properly, finding the center point of the observatory, making some simple measurements, when you plug all that accurate information into your dome control software, it is going to nail it every single time. And it's really quite fascinating when you sit out here and you watch the telescope move and the dome rotate, and it's no matter where the telescope points in the sky, if you get these numbers right, the center of the slot will always be exactly in the right place. And the whole procedure takes less than an hour to do, and that certainly is going to be a lot more of a time savings than to try and basically MacGyver it. It's easy to do, so there's no reason not to follow this procedure, and we hope you find this helpful.